Working with loops is a very important skill to master, and once you get the hang of it, you start to understand that there's tremendous value within it. The only annoying part about working with loops, specifically working with a for loop, is having to make sure that you have the syntax correct. So processing natively supports two kinds of loops, a while loop and a for loop. And you can decide really which one you want to use. Your homework, I'm asking you to attempt to use both, but you can decide which one is preferable. I personally use for loops for about 99% of the loops that I do, just because they fit with the style of programming that I engage in. But there are times and places that a while loop is going to be the more appropriate or more effective coding option, and you can decide. But generally, you can use either one in most situations, and it comes down to it's often preference as much as anything else. So the way that a while loop works is that a while loop is going to execute while a specific condition is true. Now this introduces a problem that it's possible to code something on your computer that creates an infinite loop. So with a while loop, we need to somehow make that condition that we're checking for, it has to be able to become false or untrue at some point. Otherwise, your computer will get stuck into an infinite loop of doom. Your processor starts smoking and melting, and your fan will run, and your computer shuts down, and you get really sad and grumpy and send out hate emails to your teacher, and it's just not good. So we don't want to go there. So infinite loops are bad, and while loops are much easier to create an infinite loop. A for loop is set up so that when we do a for loop, it has a fixed number of times it's going to run no matter what. The very nature of the syntax for a for loop says we want it to run a specific number of times, and that's how many times it will run, period. A while loop can just keep going as long as that condition is true. So the syntax is we use the word while, then inside parentheses we put whatever thing we are working with that we say, hey, we want to know while this is true, and while that's true, then we do whatever we want to do. In this case, I set my fill color to red, I draw a rectangle, and then I'm going to modify that condition that I am working with, while x in this case, and I am going to then change its value. So it starts out at the beginning, we'll see while x, I said it starts at 0. That's my initial value in the setup. And then 0 is less than 600 minus w. Well, let's see, w is 20, so that's 580. 0 is less than 580. Okay. Fill is red, draw myself a rectangle. Now I make while x equal to 25. The syntax that's being used here is slightly different than what we have used before. This is a slightly more abbreviated syntax, but it's the more common syntax that you will run into. So this particular line, line 27 on my screen, while x plus equals 25, is the same as writing while x is equal to while x plus 25. So those two lines of code are performing the exact same identical operation. This one is shorthand. It's a little bit less typing. My philosophy is the less typing you do, the less likely you are to make typos. So within reason, when you're coding, I always, if I have an option to use less, I generally will take it so that I can try to be a little shorter and cleaner with my code. I also think that it's a little bit cleaner and easier to read. Instead of saying while x is equal to while x plus 25, we just say while x plus equal 25. So most examples from this point onward in the semester, you will see this more abbreviated shorthand version when we're adding a value to one of our variables. We say the variable is equal to the variable plus a certain amount by using plus equals. We can also use minus equals, times equals, divide equals. So we can do all of our basic math operations with the shorthand syntax. So now that I have my while loop, while this condition is true, do this, and then change my value that I'm checking to see if it's true. Otherwise, I create an infinite loop of doom. If I run this, what we will see is a series of boxes that will now dump themselves across the screen in one chunk. Now, if you were imagining it's a loop, so you're thinking possibly in your head, you should see one box, and then the next box, and the next box, and you'd see it animate its way across. Loops don't do that. Loops execute in their entirety. So the entire loop will run before I move to this next line of code. So this entire while loop here will keep running before I can ever get to my next line of code. So I can't, so if we think about draw, where it's going 30 times a second, 60 times a second, if I create a while loop that does so much and takes so long, I'm down to like less than a frame a second. It might even be one frame for a minute, which means I'm creating potential loop of doom or something. So the while loop runs in its entirety before we move to the next chunk in our program. Remembering that programs execute in line order. So from draw, go to while, do what's in the while, and I can't get out of this until while x becomes greater than 580. Until while x is greater than 580, it will not go to this next line of code. So I could put the most awesome thing ever in that next line of code, and if my while loop became infinite, I would never get to see it. So that's one of the things to remember on loops, is that they're not going one step each frame. They go in their entirety every single frame. Which is why if you use a lot of loops and you're not careful, you can create huge performance issues where your program is going to just bottleneck and chug because it's now thinking way too hard. So if you design something where you say have 10,000 objects or particles or enemies or something inside a project, and every frame you iterate through all 10,000 objects, that can start to slow it down. Your frame rate will go from 60 down to 30, down to 20, down to 10, down to 2, down to 1, or worse. So we have to be cautious with that. So that's a while loop. A for loop is a little bit different. So when a for loop runs, what ends up happening is it's going to run exactly how many times we've told it to do so. And that is going to be based on the middle parameter that we have occurring here. So to break this down, after the word for, we have a variable I, our iterator. And it's the most common letter to use when you're creating a for loop is you use I for your first little one. If you make another loop, then you would use J. Then if you make another loop, it would be K, L. So you start at I. Tradition, as much as anything else, it could be any letter. It doesn't really matter. So we could have it be a word, and it doesn't matter. But I is the most common one that we use for this little iterator value, or incremental value that we're keeping track of. So we start out and set it at 0. Then we say, well, I is less than 20. So that means if we start at 0 and we go less than 20, that means we actually get to go through our loop 20 times. Now remember, computers like to start counting from 0. So it makes sense that we start I at 0. And then what this little line right here at the end says is, after I've completed my loop, make I one bigger. So I plus plus is shorthand. So I plus plus is the same as I is equal to I plus 1, which is the same as I plus equals 1. So I plus equals 1 is the same as I is equal to I plus 1, which is the same as I plus plus. So anytime you're just adding 1 to a value, you can use plus plus. And if you want to subtract 1 from a value, you can just use minus minus. So these are programming shorthand, programming shortcuts that are very commonly used in most coding languages. So when you construct values and you're adding one or subtracting one, you very commonly will just use plus plus or minus minus. So when you look at the code, you know, oh, that means add one or subtract one. So I'll just put parentheses around these so it's a little bit easier to see. So these three items, I plus plus, I is equal to I plus 1, and I plus equals 1, all three of those will generate the same result. And I could use any one of those, but tradition is when you write a for loop, it follows this syntax. We start at 0, and now we don't have to start at 0. It's just most times the way that we use a loop, we would start from 0. And then we set the value of how many times we want to go through, and then we add 1 to that incremental value, or our counter. So if we think of it as it's a counter, it's counting how many times we go through the loop. So the first time it's at 0, the next time we add 1 to it, it's 1, 2, 3, up to 19. That means 0 to 19, that's 20. So it makes it kind of easy to look at this and say, oh, well, that means I've gone through the loop 20 times. So as I do that, then I can choose my fill color, and then I'm going to draw a rectangle at these values. So when I run the code, we will see a series of green boxes. The green boxes, if you count them, there are exactly 20 of them. So to make it even easier to see, I will make it fewer boxes to count, and I will just say 5 and run it. And now what I will see is 5 boxes show up on screen. These 5 boxes are being drawn at my 4x value, which started out, 4x started at 0. My 4y is at 200. Thus it's down here at 200. So 0 and 200 to draw that box. And we can see the 4y width and height, that's all the same. But this little part here, so 4x plus I times 25. So one of the things that loops are really useful for doing is a very repetitive task. If you want to do the same thing over and over, but have it just move a little bit or change a little bit, it works really well that knowing that incrementer or counter, that I starts at 0. 0 times 25 is 0, so 4x starts at 0. The next time through, 1 times 25, okay, we'll add 25 to our value. So now it draws it at 25. And then the next time through, I is going to be 2. So we just keep adding in, and that allows us to create this repetitive pattern. Now, instead of using a loop, you could very easily say rect and then specify x and y positions for the first box, and then for the second box, and then for the third box, and you do it. So if you had 5, that wouldn't be a big deal. But if I said, give me a grid 100 boxes by 100 boxes, and you had to type in rect and type in all those numbers and keep straight which number is going where, eventually you're going to get really unhappy with me. More unhappy than you already are, perhaps.
Did you get some?
But is good to know, even though it's not required for the homework, is you can actually do a loop within a loop, which is useful when you are creating a grid. So there will be times later on in the term when we will want to create a grid-based structure. And this is one way that we can now draw such an item. There's other ways that we can work with it, but in this case, what we are doing is we draw a row, and then that row we populate with the columns that would go within it. And as we look at this, we will see that it creates a grid. In this case, it's creating a grid that's 5 wide and 10 tall. And if I look at the code, we can see that we do rows first. So we do the first row, and then there's 5 columns. So it draws those 5 boxes. And then it repeats and goes to the next one and draws 5 boxes. So it keeps working its way across and then down, across and then down, across then down to create that grid structure. The nested loop is not something that immediately is intuitive. None of this is probably immediately intuitive, but the nested one is decidedly not so. So use it, play with it, experiment, and see what happens when you start mucking around with different items and values. Looking at the flag example here, it took a little conniving to figure out some of these things to figure out the best way to do it. I don't know if this is necessarily the most efficient way of coding it, but it's a solution, so it works. So with this, it's going to draw 13 stripes in the first chunk of code. Then it's going to draw the blue box, and then it's going to put a bunch of stars in. And looking at the stripes, one of the things that is necessary with this is to figure out whether a stripe should be white or whether the stripe should be red. And trying to come up with a solution for that, one item that I arrived at would be to determine is, while going through this loop, is I an even or an odd number? Meaning if I divide I, which starts out at 0, if you divide I by the number 2, do I end up with a remainder? So we're trying to determine, is I an even or odd number? 0 divided by 2 has no remainder, so it fills it with red. Now if I take 1 divided by 2, well, we know that's not an even number. 1's not an even number. But 1 divided by 2 gives me, if I express it as a decimal, it would be 0.5. But in this case, I end up with a remainder of 2. So 2 goes into 1 0 times remainder 2. So the modulus operation, and that's what the percent sign represents here. This percent sign represents that we are dividing by a number and only keeping the remainder. We're not keeping, we don't care how many times 2 goes into it, we just care whether and what the remainder is. And then I'm comparing that remainder to 0. So if that remainder is 0, meaning it's an even number, the fill color is crimson red. Otherwise, the fill color will be white. So 2 divided by 2, 2 goes into 2 one time, no remainder, so then it becomes fill color red. Now we finish our loop, go back through the next time. I is now 1 bigger, I is 3. 3 divided by 2, 2 goes into it one time with a remainder of 2. So now we end up with, this is no longer true, becomes white. Now it becomes 4. 4 divided by 2, 2 remainder 0. So we just keep doing the process over and over and over, and it creates this loop to give us the value of red, white, red, white, red, white. So we create this alternating. Now we could write a different kind of structure that wouldn't be quite as complete. So we could say I divided by 2, and we'd have to figure out how to determine, whether it's has a whole number or not. So we could come up with some more complex math, but the modulus math operation is really useful for creating kind of this sequential of on, off, or even odd math figuring. So in the functions file, as you look at that, there's a little bit about the generic of what is a function. And there's a nice whole chapter on functions and objects in your book. Chapter 7 is function. Chapter 8 is objects. So we're going to be hitting those pretty hard next week. So you really do need to make sure you've tried to gain some understanding. You have to read, play with it. But here's where the functions project is. When I look at this, a function has a return type, a function name. It may take arguments, it may not. It does something. The function returns something, then that corresponds to our return type. If a function does not have the word return in it, then a function has that magic word called void. So a previous class someone said, what's that void mean? Void means this function, as we see it set up and draw, do not return anything to us. They just execute. If we have a function that we say, that function, we send some numbers to it, and we say, do some math with those numbers, add them, subtract them, multiply, divide, square root, powers, whatever we want. and then return to us whatever that final value is, then that would be a function with a return type. So our function, instead of the word void, may say float, or it may say int, or it may say boolean, depending on what we're trying to claim back from that function. So we will be making functions that give us back information. So they don't just run, but they give us something back in return. So we will be doing that next week. So set up and draw our functions. So you've already used functions. Ideally, what we want to do when we're working with a function, and these ending ones, I'm just going to get rid of those for now anyway. I'm not talking about those tonight. But when we work with a function, what we want a function to do is typically a function should do one primary task or activity. So with that, instead of just putting background, so when I look here, I see draw. Okay, there's a command here, and then so I have to think about what are these different items doing. But really what it is I have void clear background, and now what's sitting inside that would be the wrong command there, I missed. What's sitting inside clear background is going to be that background statement. So that's clear background. Now I have void update, and within update, well, updating is where I am going to be modifying the Y position of my object. So it really is going to be that line right there. So there's my update. So I'm updating my ball. I could call it update ball if I had multiple objects, but we're going to end up using functions called update and display a lot, so I'm just going to leave that. Now I have these lines here, this if statement where I say, hey, have I hit the edge or not? Well, really what is happening at that point is I'm saying check boundaries. So I want to check the boundaries for my project. I'm finding out if I've hit the boundaries. If so, I want to move to a new position. So I say, hey, check the boundaries. Okay, and now the final thing that I'm going to do is display, if I can type correctly still. And with that, I can now grab my fill color and my ellipse, stick those in, paste. Now all of this, comment that out. Now if we look at what's going on inside draw, we can see inside draw, actually we'll just get rid of all of this for now, don't even need it. Draw says clear the background, update the ball, check to see if the ball hit the boundaries, and now display the ball on screen. Updating meaning change its position to whatever it needs to be. So when I look in my draw loop right now, suddenly that list of functions that I'm trying to access, it's almost more readable because I'm now specifying what that is. Clearing the background, updating the position of the ball, checking to see if the ball hit the boundaries, and now finally saying display the ball on screen. Now, yes, it's more lines of code now, but when your items of updating or boundary checking or display become significantly lengthier and more complex, suddenly your draw loop here is a much more understandable, a much more comprehensible item because it just is now calling on other kind of smaller tasks or smaller routines that we want to have happen. So it does the same thing, but arguably in a little easier to understand fashion. And this is what the use of functions is really going to become, is we have more organized code. Instead of just looking at the code where it's a whole bunch of lines and you're left going, okay, what's this chunk of lines do? What's this line do? What's this line do? They're now organized into easier to digest, easier to parse, easier to understand pieces. And then those pieces can become more usable, that I can even take pieces from project to project. Or if I realize I get a good function in one project, I can go paste it into the next project. If I just have 200 lines of code and I'm looking for something, trying to find it, good luck. It doesn't work very well.
So that's basically a table.
One final difference in this versus what we've done before, you will notice that I put all of my variables, because they're the same type of item, all on one line with commas. instead of having everything, all of my variables, well, that one doesn't have a lot, but all my variables on separate lines, if they're all the same kind, in this case all integers, I could have put them all on the same line. Now if I had a series of integers here, then I could say int, and I could say, so if they were integers, I could put integers on one line, floats on another line. You can organize your variables, multiple ones with commas between them on the same line. Sometimes that gets easier because when your program has 20, 30, 50, 100 different variables, putting them all on separate lines gets a little unwieldy. So I like to group variables that are related together and put them, if they're the same type, all on one line with commas. You don't have to, but you may find that makes more sense in some of your later projects. So I thought I would introduce that technique now.